Dear students, today we are going to see another experiment, simple harmonic oscillations of cantilever. What is meant by cantilever? See the image here. A beam, if it is fixed at one support and another end if it is free, such a setup is called as cantilever. Now, for this cantilever, we are going to determine the elasticity of this beam. Okay. So, that is nothing but the Young's modulus of the material of this cantilever. Okay. Let us see the formula here. Young's modulus of the material of cantilever, Y is equal to 16 pi square L cube divided by BD cube into M2 minus M1 divided by T2 square minus T1 square. Let us see each and every term. L is the length of the cantilever. Length of the cantilever represents, okay, from the fixed support, what is the length of the beam? Okay, so this is nothing but the L value. Okay, what is B? B is the breadth of the scale. How we are determining the scale breadth by means of the vernier caliper? Already students are familiar about it. Okay, and D is the thickness. Okay, by which it is determined by means of the screw gauge, thickness of the scale. Okay. Now, M1 is the mass added to this cantilever. We are taking M1 and then M2. Okay, M1 it is 50 gram and then M2 it is 100 gram. How much mass is connected at the tip of the cantilever? Okay, that is the mass. Okay, once we have to determine the reading for 50 gram, that is M1, and another time we have to determine for M2 is equal to 100 gram. Okay, now T1 and then T2 are the time period of oscillation of this cantilever. Okay, time period of oscillation means the time taken for one complete oscillation of the cantilever. T1 is the time period when mass M1 is connected. T2 is the time period when mass M2 is connected to the cantilever. Now, let us see the setup here. Let us take a particular length. L is equal to 80 centimeter. So, at the 80th centimeter, we have to fix the beam onto any of a support by means of a G clamp. This is the G-shaped clamp. To the tip of the beam, okay, we have to connect the weight hanger, and to that weight hanger, we have to connect 50 grams slotted weight. Okay, and then we have to just slightly we have to press this tip. Okay, thereby this will be set into oscillation. Let us see the setup now. This is the cantilever, okay, our ordinary scale, okay, 1 meter scale where it is fixed at 80th centimeter. So, 80 centimeter it is outside, it is extending, and then remaining 20 centimeter it is on the table. Okay, this is our G clamp. And then to the tip we have connected our weight hanger, and then here we have connected the slotted mass, okay, 100 gram it is connected here. Now, this is our stopwatch through which we are going to determine the time for oscillation. Now, the time for 20 oscillations have to be determined by means of the stopwatch and then stop clock, and then it have to be, capital T have to be determined by dividing the time by 20. Now, let us see how we are supposed to do the experiment. Now, I am going to just press the tip and then going to calculate the time for 20 oscillations. This is the way it will oscillate. Okay, the beam tip it is moving up and down. Okay, so just by starting from any one particular oscillation, okay, we have to switch on the stop clock. Now, let me start the trial now. Just press and leave it and then start the clock from one particular point. Now, let us start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So, the time it is 15 seconds. So, 15 seconds is taken for 20 oscillations. So, therefore, the time for one oscillation is equal to 15 divided by 20. Thereby, you will be getting the time for one oscillation. Now let us see the tabular column. See here the length of the cantilever it is represented. Okay, for 3 different lengths we have to take. For 2 different masses we have to do the procedure. Now mass M1 is equal to 50 gram, mass M2 is equal to 100 gram. Now the time for 20 oscillations. Actually we have to take for 2 trials. Okay, if both are more or less similar alone, okay, it is considered. If there is any variation, we have to go for the 3rd trial. Now for 90 L value, see for mass M1, the trials are 10 seconds, 10 seconds. So the average it is 10, and then if we find the time for one oscillation, okay, 10 divided by 20, it is nothing but 0.5 seconds. Like the same for mass M2 is equal to 100 gram. For the same length if we consider, trial 1 is 13.5 seconds and then trial 2 is 14 seconds for 20 oscillation. Okay, take the average of it and then divide it by 20. We are getting the time for one oscillation as 0.6875. This is T2 value and this is T1 value. Okay, so with this L value and with this M1 and then M2 value and then with this T1, T2 value, we have to do the calculation. Okay, that is L cube into M2 minus M1 divided by T2 square minus T1 square. So finally we achieve 0.1637 as answer. Like the same we have to do for 2 different lengths, that is for 80 centimeter and then 70 centimeter of the cantilever length. Finally we come out with the average of 0.1847 kilogram meter cube per second square. Okay, so now let us pass on to the next. Dear students, determining the breadth of the beam by means of vernier caliper and then thickness of the beam by means of screw gauge, it is already familiar for you all. Okay, now just we will pass on to the final answer alone. Now the determined breadth of the scale, it is 2.566 into 10 power minus 2 meter, and then thickness of the scale D is equal to 5.754 into 10 power minus 3. Now we can do the final calculation. Already the calculated value for this formula, it is 0.1847. Okay, now we have to introduce the breadth and then thickness with the formula, where y is equal to, young small as y is equal to 16 pi square, okay, divided by BD cube, and then this answer along with the L cube, it is identified as 0.1847. Put the values for pi square and then breadth and then thickness. The final answer it is y is equal to 0.596 into 10 power 10 Newton per meter square. Actually, okay, it should be around 1 into 10 power 10. Okay, as our scale, okay, our beam which it is considered as cantilever, okay, it is its elasticity have got lost being old. Okay, it is coming nearer to 0.6 into 10 power 10. So it is a perfect value. Okay, so that's why thereby we are finding the result as Young's modulus of the material of the cantilever as y is equal to 0.596 into 10 power 10 Newton per meter square. Thank you.